Welcome back, everybody. This video we'll be talking about graphical representations of functions and three big traits: x-intercepts, y-intercepts, and slope. Alright, so we'll start off with this one. Here we have a total cost of a taxi cab ride. The y-axis is the cost of the taxi cab ride, and the x-axis is the distance traveled in miles. So what is the slope and what does it represent? Alright, well, little calculations for the slope here. We need a couple of points here. Maybe we can find them that are right at the crosshairs here. Maybe this right here. And then another point looks like possibly up here at the very top. So figuring out the slope, how much do we go up and how much do we go to the right? Well, it looks like we go up 2, 4, 6, 8, 10. So up 10 for the rise, and then we go 1, 2, 3, 4, 10 over 4. That's going to reduce to 5 over 2. That is the slope. I'm going to change it to a decimal, 2.5, and it is the change in the cost over the distance miles. So basically, another way of saying it is how much it costs per mile. Alright, so $2.50 for every mile traveled. And the y-intercept happens to be, looks like it's about 3, so it looks like the cost of the taxi, you got to pay $3 just for the ride, but then it's $2.50 per mile thereafter. So this is showing the slope of the line. In this case is actually the fee, the cab fare per mile. It's the rate. What's the cab rate for every mile that you plan to go? Let's look at another one here. This one is distance left to walk. It says Michael's walking from home to work. The function graph represents the remaining distance to his work in kilometers, x hours after he starts walking. What's the meaning of each key feature of the graph? And so, yeah, three key features here. We have slope, x-intercept, and y-intercept. Alright, first of all, the slope. We're kilometers per hour. Alright, and we can calculate that with a couple of points here. We're starting up here, and looks like there's another intersection right here. Alright, so looks like it's going down 1, 2.5, 2.5, and for over 0.5. And 2.5 divided by 0.5 is 5, so he's traveling at a rate of 5 kilometers per hour. Alright, the x-intercept, what does that mean? Down here, well, the x-intercept has coordinates. Looks like it's probably about 0.8, 0. And what does it mean? This is the number of hours it's going to take to walk. So 0.8 hours to walk from home to work. Alright, and the y-intercept, we see the coordinates for the y-intercept 0, 4. So that is telling us that he has 4 miles to work, or 4 kilometers to work, or 4 kilometers to walk from work. Alright, so just kind of a quick explanation, labeling each one, knowing what it means. So the x-intercept's telling us it's going to take just a little bit less than an hour, 0.8 hours. Y-intercept's telling, okay, he has 4 miles from work, so that's how far he has to walk. All right, next one, sort of a true-false situation here. So we got the graphic designer charges an hourly rate. In July, the only expenses is for advertising. The function graph models the designer's net income Y for the July for X hours of work. Select true or false to describe each statement. So let's looking at this. So we have the slope of the line, and that is telling us how much money he makes per hour. Y-intercept looks like he had to put some costs up front for his work. And the x-intercept is sort of like the break-even point here. Okay, so let's go through and say each one's true or false. It says the x-intercept represents the amount the designer charges for 1 hour of work. No, that is incorrect. X-intercept is sort of his break-even point. It says the difference between 0 and the y-intercept represents the amount the designer spent on advertising. Yeah, so he had some costs there, $300 cost. This amount of money right here, he's in the hole. He needs to work to make up that to get his advertising costs recouped. And lastly, the slope represents his hourly rate. That is right, how much he makes per hour. Okay, and we can go through and compute that if we need to. Looks like 1 up, 1 right, 1, but 1 means 100. Up 100 and then right 2. So it looks like he makes $50 an hour, 100 divided by 2. All right, let's look at another one here. We have a situation at a construction site. Workers are moving dirt from a pile to fill a hole. The function graph models the volume dirt Y in cubic feet remaining in the pile after X hours. What do the key features of the graph indicate in the situation? Let's go through them again. We have the slope. We have x-intercept. And we have the y-intercept. All right. Slope is how much dirt is removed per hour. Remember, slope's always a rate. Dirt per hour, and it's in cubic feet. All right. The x-intercept is basically the entire amount. The x-intercept is down here at 6. So it tells us took 6 hours. The entire pile is removed after 6 hours. You can see kind of like the coordinates here, 6, 0, 6 meaning the amount of time has passed, and 0 meaning the amount of dirt left. So down here you can see it's lined up with 0. That's 0 cubic feet of dirt left. The y-intercept's like at the very beginning. The beginning is starting amount of dirt, 450 cubic feet of dirt. And that is to start. Think of y usually, not every problem, but most cases, the y-intercept's the starting amount, and the x-intercept refers to the ending amount or the ending time that has passed, how much time has passed in a situation. All right, and the last one here, we got a multiple choice here. We got a couple right answers. 2 functions graphed of 2 people driving. A typo there. Something didn't copy very well. Yeah, we had some typos here. So we're just going to answer whether these 4 items are true or false. So we got Tavin and Celia are driving. The slope of each line basically says the speed or how fast they are driving. You can kind of tell who's going faster, whoever has the higher slope. Now looking, it's kind of hard to tell at first. Looks like Tavin started out 10 miles further away than Celia, but Celia has the steeper slope, so Celia is going faster. Tavin is going slower. So we could label that Celia drove at a faster rate. That's definitely a true statement here. All right, and then the intersection is happening right here. Notice the coordinates 1, 60. And it says the intersection, let's check A here, indicates the time in hours when Celia and Tavin are the same distance from the city. Yep. All right, that is a true statement. That's when their distances are the same. See, distances over here, it says at 1 hour, they both are at 60 here. All right, but B and D here are the false statements. All right, after looking at these 5 examples, hopefully you maybe have just a better idea of how to interpret different parts of graphical functions, looking at x-intercept, y-intercept, and slope. Thank you for watching.